Hi guys, welcome to Calculus Crash. Today we're going to be doing an optimization problem. The basic idea for an optimization problem is to determine some kind of relationship, take the derivative of that relationship, set it equal to 0, figure out the maximum or minimum values. So the question is as follows. A piece of wire 100 centimeters long is cut into two pieces. One piece is bent into a square, and the other piece is bent into an equilateral triangle. How should the wire be divided to maximize or minimize the area enclosed by the triangle and square? Two very important pieces of information here, that we're making a square and we're making an equilateral triangle. So that tells us right away some very important geometrical rules. So first thing we should do is draw the wire. All right, so we've got a wire here, and in total it's 100 centimeters in length. And we're going to divide it into two pieces. Now we don't know how much is going to go to the triangle and how much is going to go to the square. We need to figure that out. So let's just draw here. On this side we're going to use X amount, and on this side we're going to have Y left over. So we're going to cut it at any point along the wire and end up with X on one side and Y on the other. Now, of course, we know a very important relationship already, and we're going to say that Y is equal to 100 minus X. So if we cut off X from 100 centimeters, then what we have left over is 100 minus X. So we have a relationship between Y and X, and that's important. Now let's take these individual pieces and turn them into squares or triangles. So first, for the X piece, I'm going to turn that into a triangle. So we're going to take that, we're going to fold it into an equilateral triangle. What does it mean to be an equilateral triangle? It means all the sides are the same. So if we take X and we fold it into a triangle, equilateral, we have X over 3 on all the sides. Now, what is the area of this triangle? So I'm going to write it here. The area, A of T, we'll use T for the triangle, is equal to 1/2 base times height. That's just the formula for the area of a triangle. So we need to figure out the base. Well, that's easy. The base is just X over 3. And the height. The height is a little more complicated. We're going to have to use Pythagoras Theorem to figure out the height. So I'll just draw a half of the triangle, a little bit bigger here. So we know this side is X over 3, and this is only half of one side, so this is X over 6. Now we need to figure out what this is. I'll call it H for the height. Using the Pythagoras Theorem, we have X squared over 36 plus H squared equals X squared over 9. Now we solve for H. H equals X squared over 9 minus X squared over 36 and the square root of all that. So if we simplify, we got to put this on a common denominator. We have 4x squared minus x squared, all divided by 36. So finally, we have x over 6. So 36, we can take the square root of that. We can take the square root of x squared. And what we have left over with is the square root of 3 on the inside. So this is the height. Using that, we can figure out our expression for the area of the triangle. So it is 1/2 times the base, which is X over 3, times the height, which is X over 6, the square root of 3. So let's write this a little bit tidier. We've got on the bottom 2 times 3 is 6, times 6 is 36. So in the front, we've got the square root of 3 divided by 36, and then an x squared. Okay, I'm just going to put a little box around it because this is going to get big and this is an important piece of information. Okay, so we have an expression of the area of the triangle. Now we need an expression for the area of the square. This one won't be quite as much work. So I'm just going to move it over here. We're going to take this y piece and we're going to bend it so into 4 sides, which all have the same width. I'm just going to use y for the time being. So each side is y over 4. And the area of a square, we'll call it a of s, is equal to just base times height, which would be y squared over 16. Now we need to substitute in what y is. So it's 100 minus x squared divided by 16. So we have the area of the square written in terms of x now. Now what are we trying to do? We're trying to maximize or minimize the area enclosed by the triangle and the square. So we need to write out a formula for the total area. I'm just going to call that A. The area, the total area, is equal to the area of the triangle plus the area of the square. And that's equal to, area of the triangle is the root of 3 over 36 x squared, and the area of the square plus 100 minus x squared divided by 16. So this is our area function. And what we want to do is maximize or minimize this. In order to do that, we need to take the derivative and set it equal to 0. So the derivative of this first term, we bring a 2 down, and we have root 3 over 18 times x. So remember the 2 goes in front, 2 over 36 is just 1 over 18. Plus, I'm going to use the chain rule here. The 2 comes down in front, times 100 minus x to the power of 1 times the derivative of the inside. The derivative of 100 is 0. The derivative of minus x is minus 1. So let's simplify this a little bit. Root 3 over 18 x minus 1 over 8. 2 over 16 is 1 over 8. And the minus 1 comes out front. 100 minus x. So let's keep simplifying so we can get our x's together. Root 3 over 18 x minus 100 divided by 8. I'll just leave that. We can simplify that later. Plus x divided by 8. So let's gather up our x term. So if we factor out an x, we've got root 3 over 18 plus 1 over 8 minus 100 over 8. So let's see, we can put 4 into it. 4 goes into 125 times, and 4 goes into 8 2 times. So that is A prime. Now what we want to do is set that equal to 0 and solve for x. So what we need to do, x equals 25 divided by 2. And this whole thing is divided by, but I don't want to write it like that. I'm going to go times 1 over this thing. Root 3 over 18 plus 1 over 8. 1 divided. This tells us that if x is equal to this number here, let's actually try and simplify this horrific thing here. We'll leave the 25 over 2. But here, I'm going to factor out a 1 over 2. So we have root 3 over 9 plus 1 over 4. You know, you could always just use a calculator to do this, but we're not going to use a calculator. We're going to try and simplify. So we've got 25 over 2 times a half. Put that half there. Times, now we need a common denominator for these. 4 root 3 plus 9 over 36. And that's equal to 25 times 36, because the 36 can come up to the top now, divided by 4 root 3 plus 9. What is 25 times 36? I have no idea. What is this? Right? We solve for x, right up here. X is equal to this number right here. Now what happens when x is this number? Well, x is, if we go back to the beginning, x is the amount of wire we used for the equilateral triangle. So if we use this amount of wire for the equilateral triangle, and the remainder, 100 minus that, for the square, are we maximizing or minimizing the area? Well, we need to figure that out. So I've gone down too far here. I'm going to rewrite this expression. And I've actually already used a calculator to figure out this answer. And I'm going to use that. So x is equal to 56.5. Okay, this value here is just 56.5. So that's right. We're using 56.5 centimeters for the triangle. And that means y would be, what is that, 43.5 centimeters for the square. So will this maximize or minimize our area? Well, intuitively, you would assume that to maximize our area, we would probably want to use all of the wire for the square, because the square is the most optimum area efficient. But let's just imagine that we didn't know that. So how would we figure out if this is a minimum or a maximum? Well, if it's a minimum, then we know that our function should be decreasing and then increasing. And if it's a maximum, our function should be increasing and then decreasing. So it's up to us to take a look at this function here and figure out what's happening to it. So if we take a look at this derivative function and figure out where it's positive and negative, then we can decide if this value here is a minimum or a maximum. So remember, if your function is decreasing, then the derivative is negative. If your function is increasing, then the derivative is positive. So we need to figure out where this derivative is positive and negative. In order to do that, we can just draw a number line. And we just put all of our roots, or where this equation is 0 on it. It's only 0 at one point, and that's 56.5. So we know the value is 0 here. And we need to test a number on either side of 56.5 to figure out if the derivative function is negative or positive, and therefore the actual area function is decreasing or increasing. So let's try a number to the left of 56.5. What's a good number? How about 0? When x is 0, then this whole value here is 0, and all we have is minus 25 over 2. That's a negative number. So we know that our derivative, maybe I'll just write a prime here. so we know we're talking about derivative. Our derivative is negative when x is less than 56.5. Now let's check the other side. Let's choose a number bigger than 56.5. How about 1,000,000? I don't want to choose a smaller number because I don't want to actually plug it in and calculate it. But if we choose 1,000,000 for x, 1,000,000 times this thing in here, well, this is some number probably around, I don't know, root 3 is 1 point something divided by 18, so it's 0.1 plus, I don't know, it's around 0.2, let's say. Or 0.3. 1,000,000 times 0.3, that's 300,000 minus 12.5. It's positive. It's a number bigger than 0. So we're all positive on this side. That means our function is decreasing, and then it gets to the root where it stops decreasing and starts increasing. So this here, this value of x, will minimize, give us a minimum for our area function. We'll minimize the total area. Let's go back to the original question. So we've just figured out where we're going to minimize it. In order to minimize it, we need to use 56.5 centimeters for the triangle. Now, what about maximizing it? With this equation here, when we set the derivative equal to 0, it only gave us one value. It only gave us x equals 56.5. It only gave us the minimum. So how do we figure out what the maximum is? We haven't tested the limits of the domain yet. What are the possible values of x? The limits of them. Well, we could use nothing for the triangle. So x is between 0. We can use nothing for the triangle, use it all for the square. Or we can do the opposite. We can use it all for the triangle and use nothing for the square. So let's check that. If x is 0, what is the value of our area? So we need to look at our area function. Here it is up here. So the area of 0 at x equals 0 is equal to, well, this whole term is 0. Then we have 100 squared over 16. I'm just going to leave that for now. Now the area, when we use all of it for the triangle, when x is 100, that would be, well, this term here is 0, so 100 minus 100, root 3 over 36 times 100 squared. So which one is bigger? It may not be clear immediately, but if you bust out a calculator and evaluate these, you'll find out that a of 0 is bigger than a of 100. So this is our maximum. If we want to maximize the area, we need to use 100 centimeters, or all of it, for the square. And don't leave any over for the triangle. That kind of makes intuitive sense. Squares are the optimum area. They have kind of the maximum area per unit perimeter, you could say. Well, maybe circles are better. I'm not sure. I'd have to check that. But compared to squares, triangles are not quite as good. So we found out how to maximize and minimize. Maybe I'll just summarize the answer down here. So to maximize, use all the wire for the square. And to minimize, Now this is kind of interesting. We don't actually want to use all of the wire for the triangle. There is actually a mix, and we determine that. We'll write it in terms of the square, 43.5 centimeters for the square. Now, if you want to figure out what those areas are, you can just plug 100 in for the area formula up here. And then you'll figure out the area enclosed if you use just the square, the maximize. And then if you want to figure out the minimum area, you would just plug in 43.5. Figure out the minimum area. Okay, guys, thanks for watching. That was a bit of a long one. These optimization problems can be a bit tricky. There's a lot of work involved in them. If you have any questions, if something didn't make sense, just leave it in the comments, and I'll be happy to get back to you. Until next time.